All right. Good afternoon, guys. So, last class we have seen this ICMP R, proxy R, Telnet, and SSH. Correct. So, basics are over. So, from today we'll start routing. Okay. So, make sure you understand this ICMP R. Very important as per interview because they will ask multiple questions in those things areas. Not multiple questions. At least one or two questions they'll ask you from this ARP and ICMP. Okay. And especially that proxy ARP. It depends on interviewer to interviewer, but still you can expect questions from ARP. When they ask what is ARP, don't say address resolution protocol, just say define what is ARP, why it is used. When source tries to ping the destination and it doesn't have the MAC address, to resolve that, we're having this address resolution protocol. Okay, like that you should give the answer. All right. And then you have Telnet SSH, that is to take remote access. So today I'll take you to lab and we'll see how we are taking access through Telnet. Okay, so three ways you can take access. One is physical, other one is through Wi-Fi. We have seen that power adapter, correct? In that power adapter, the Wi-Fi was connected, correct? Through that Wi-Fi, we'll connect and we'll get the access. Other one is through RDP, remote desktop login. Okay, so through that, we'll be able to, they'll give you a link and a port number, give the link port number, and then we have username and password. If you give that, you will connect to that rack. Okay, so today, three ways how we are going to get the access, we'll see. Okay, so today we'll finish a little early class and then we'll go to lab. Okay, so today we are going to learn routing protocol. See, routing. Today we are going to learn routing. So before routing, we should know what is correct. What you're not able to get? Under the domain name, we are creating the cryptographic keys. Some why it should come right? Huh? Right, I'll show you. One of your friend has problems. Okay, usually we don't discuss this now, but let me see. See, before going to routing, you should know multiple things. What are the things? What is router? First of all, you should know what is router. Then what is routing? What is route? What is routing table? What is routing protocol? What is routed protocol? You should know the difference between each and everything. Then it makes sense. Straight away jumping into routing doesn't work. Understand the concept completely. Today we'll learn the basics very thoroughly. Tomorrow we'll see the practicals. What you're gonna learn in routing, static routing, default routing, OSPF. That's it in your CCNA. But we'll take 4 days. We'll learn the basics one day, static default one day, OSPF one day, RIP version 1 to EIGRP another day. So that you can understand this routing completely. Okay. So first we are going to learn what is routed protocol. I already told you what is routed protocol. What is routed protocol, guys? It carries data from it carries data from, or you can say source to destination. It carries data from source to destination. That is a router protocol. Correct. For example, you can say TCP IP. Correct. This is a routed protocol. What is routing protocol? It doesn't carry data. Correct. It does not create the, see, it does not carry data, doesn't carry data. Instead, it creates the path for it. Instead, it creates the path for the routed protocol to Or just say router protocol. This is enough. It doesn't carry data. Instead, it creates the path. Okay. And then it also helps router to share the routing table information. Okay. This point you will understand while I do the practicals. Okay. And here, what are the examples? You can see EIGRP, OSPF, your RIP version protocol, your BGP. Okay. These things are your routing protocols. IP domain name cisco.com. It is working. Correct. So first you give the host name, then you create the domain name, and then what? Crypto key, generate RSA, general keys, modulus 2048. Done. Now username, I'll say CCNA, privilege. Oh, username, CCNA, privilege 15, password 123, enter, line VTY 025, correct. Login, local, transport, input, SSH. I'll go to this. Oh, I did not create IP. Interface gig 0/0, IP address 1.1.1.10. Oh shit. Exit. Do ping 1.1.1.1. Pinging. Now go to this. SSH -L. What is the username? CCNA. What is IP? 1.1.1.10. Password 123. 123. Enter. You got the access of R1. Now you can say enable. Like this, you can do all the comments. Okay. Because comments? No, if you give privilege 15, it will work. See here, why you did not get is because the see here IP domain name until you have to give. That's why you got problem. See IP DOM, your tab will not work because there are multiple things. See, you have domain lookup, you have domain name. Correct. You have three things. So until here, it is everything is common. This is also common. Until here, it is common. So if you give domain -n, the name will work. See, I'm giving DOMAN, domain. It will not work. I'm giving tab, it's not working. I'm giving hyphen, still it's not working. I'm giving n, now name will work. So that's why you got this problem. Okay. All right. Is it clear now? Huh? What happened? Okay. Now come to your router protocol and routing protocol. So router protocol, it carries data from source to destination, and routing protocol, it creates path instead of carrying the data. Okay. And then it helps the router to share the routing table information. See, this point you keep it remember, you will understand in upcoming class. Okay. What is a router now? So router, it is a networking device. It is a networking device used to send data from one network to another. Another. Correct. That is a router. It is a networking device used to send data from one network to another network. Within the network, you don't need router. With a switch itself, you can communicate to multiple devices within a network. Okay. What is route? It is the it is the best path for the source to reach destination. That is a route. That means if I am having multiple paths to reach third floor, that is one way, two way, another, there is a three way. So which way I'll choose? I'm choosing this way. So that is the best path. Okay. Likewise, I will have the route in my routing table. So that is called route. It is the best path to reach from source to destination. Okay. And then you have, I'll give time to write, don't worry. First, you can understand it. Routing. What is routing? It is the process of choosing the path for the router to send the data. It is the process of choosing the path. So what does your routing do? It will choose the path for the router to send the data from source to destination. What is a router? It is a networking device that is used to send data. So how it is sending data? Through routing. Through routing only it will know I have to send like this. What is a route? That is the best path. Okay. A clear difference you should have between these things. And what is routing protocol? It creates the path. Okay. Okay. Write down these things. Write down. Written. Write down. Write. See, in your CCNA, you're learning routing for 4 days. Correct? Actually, it is 3 days class. I am making it 4 days. Okay. How long you will learn routing in CCNP? 5 weeks. So 25 classes you will learn only for routing. Okay. So that much you will learn there. Here only basic level you're going to learn. EHRP, like OSPF, you have 7 LSAs, we say. Okay. But in your CCNA, you learn only 2 LSA. Like that. Only basic level you will learn in your EHRP, OSPF. Even static routing. What Dinesh written? Right. Done. First bench. What's your name? Uday. Next we'll learn. I'll give you some theory parts. You can write it down. Static routing. Default routing and dynamic routing. So what is static routing? So name itself, it says static, correct? So each and every destination we are going to configure in the router. Okay. That means you can say for manually, first of all, we say manually configure the manually configure a route for each and every destination. Each and every destination. That is your static routing. What is default routing? Manually configure route for all destination. So here the router, the router, the routes are automatically defined. Defined with the help of dynamic routing protocols. So also in this, we are forcing routers to. Is it very oh, is it visible right for till last? Visible right? Forcing routers to join a dedicated multi multicast group in dynamic routing. Routing procedure initiates interface and these then towards the neighbor interface. Neighbor routers interface using multicast address to update the routing table. Write down these things. I will explain each and everything. Okay. What's Sandeep? Written already. Kishore is your friend.
Yes.
How? Like PG or
Classmates.
from school only? He did CCNA with me. You know. He told me yesterday. I took his interview. He told you. What did he say? Sir is asking too many questions. He said. Huh? He said. Okay. I'll meet him in next interview. I did not dig him in the interview. I just went easy on him first time. But he put a lot of hard work. First day he came to me, sir, I have this problem. I gave him all the notes. Every time he prepares well. Even his communication skill was not up to the mark. But every day he attend this communication class. Now he's, progressing good. Don't see his notes and come to class. I'll find it out. Okay? All right. So, first we are going to learn static routing. Before that, I'll give you the AD values also. Wait. Okay. So here, what is routing? So network routing is the process of selecting a path across one or more networks. The principle of routing can apply to any type of network from telephone to public transportation. In packet switching networks such as internet, routing selects the path for IP packet to travel from origin to their destination. These internet routing decisions are made by specialized piece of network hardware called routers. How simple it is definition? Correct. So this is for understanding purpose. Whatever I given you, understand, try to understand from there only. Okay. So routing means what? Read it out. It is the, that's it. Simple. It is the process of choosing the path from the data to send from source to destination via this router. Simple. Okay. And here you can see what is route. So route is the best path selected by router to reach from source to destination. What is a routing table? So routing table is a collection of routes to transfer data from one domain to another domain. Write down this routing table in your note copy. So you have routed protocol, routing protocol, router, routing, and routing table. Everything has a different meaning. So a question might be like anyway, they might ask you difference between route and routing table, routing and router and routing table, router protocol, routing protocol. Written. So what is an IP? So Internet protocol specifies the origin and destination for each data packet. Routers inspect each packet's IP header to identify where to send them. Okay, through your IP, they will know where to send. That is your IP. Now we have types of routing protocol. Okay, so as of like CCNA, like I said, we have static, default, and OSPF. That's it. But we are going to learn EIGRP also. And in your RIP version, we are going to learn version 1 and version 2. Okay, like this we will learn. So first of all, we'll see what is static routing. Okay, so static routing, we are going to static itself what? Manual, correct? So manually we are going to configure each and every destination. That is your static routing. For example, I'm having R1, R2, R3, R4, and R5. Okay, so these are there. So this will be one network. Okay, with directly connected. This will be another network, third network, and four networks we have. Correct. For this router one, you will understand this network because they are directly connected. Correct. But he has no idea what is this network two. So in your router one, I will add route network two and network three and network four. 2, 3, and 4 I will add here. Because he is directly connected with only one network. He doesn't know idea about 2, 3, and 4. So I'm going to connect this 2, 3, and 4. Okay. Likewise, in your fifth router, he knows 4, but he has no idea about 1, 2, 3. So here I'm going to manually configure this 1, 2, and 3 networks. Okay. Likewise, in your router 2, 1 and 2 are directly connected. Correct. So he has no idea about this 3 and 4. So for this third network and fourth network, I'll give routing. So tell me what will come for R3? 145. There is no 5 network. Only 1, 4. So if I add another router, then it will become 5 network. This is fifth router. Okay. All right. Now for R4, 3 and 4 are directly connected. 1, 2. Likewise, each and every destination we are going to configure manually on each and every router. That is your static routing. Okay. What is default routing? I'll show you in practicals. It become very easy. Okay. So again, manual default routing is also manually we are going to configure. Okay. Other thing we have is dynamic. Okay. So in our day-to-day life, we are using this dynamic routing only. Because dynamic means what? Automatic. So automatically it will choose the path. Okay. And in your AIGRP and OSPF, multiple concepts are there which you will learn in future. Okay. So first of all, under this dynamic routing, we have two things. One is IGP and EGP. Okay. So IGP means same autonomous number, same AS number. EGP means different AS number. Okay. What is this AS number means? See, if I'm having an organization in Bangalore, okay. So multiple routers are connected. Like this, multiple routers are connected. And all the routers will be same autonomous number, that is 100, for example. They will all be configured as AS number 10. So then they will be able to communicate. I have another branch in, this is in Bangalore. This is in my Hyderabad. Okay. And they are connected in AS number 200. Okay. So these routers within this AS number, they'll be able to communicate, and the routers which are in BLR in same AS number, they'll be able to communicate. But for Bangalore bands to Hyderabad bands to communicate with each other, which are in different AS number, then your EGP protocol is required. Okay. So within the same autonomous, we are using interior gateway protocol, and that is exterior gateway protocol. Okay. So this is the difference. This is same AS number, that is different AS number. Okay. And under this IGP, we have multiple things. So distance vector protocol, link state, and hybrid. We will see what is distance vector, link state, and hybrid. Okay. Any doubt as of now? Everything clear, right? First, we'll learn distance vector. Write down for distance vector. Router is not keeping topology information. It is classful by nature and do not support VLSM. Link state. Each and every router consists topology information. It is class less in nature and support VLSM. Okay, VLSM and your OSPF. PF is a link state protocol. OSPF is a link state protocol. Then we have hybrid. It is developed by Cisco, which consists features of distance vector, as well as link state. Link state, and it supports VLSM. So your EIGRP is a hybrid protocol. These notes are very important while you're going to prepare. Okay. Okay, guys, written. Online, guys, written. Yes. Okay. So now we'll see what is this distance vector and how it works. R8. Okay. So my source is R1. Destination is R8. Okay. So I have to go to R1 to R8. So how many ways I have? 3 ways I can reach the R8. Correct. So how many hops? Your distance vector protocol metric is hop count. Okay. So write down in distance vector hop count metric is equal to hop count like this. Under distance vector you can write metric is equal to hop count. Okay. So this distance vector protocol, that is, which is the protocol which is going to work in distance vector is your RIP version, RIP. Routing Information Protocol works on your distance vector. That means it is going to calculate the hop count between the source and destination. So to reach from R1 to R8, if I have to choose the first path, if I have to choose first path, that is via R2. So hop count is, so there is one router here and the second router you will reach here. So hop count will be 2. Okay. And if I reach by a second path, it will become 1, 2, and third router you will reach here. So hop count is 3. And there is another path. So here 1, third path 1, 2, 3, and fourth router you will reach here. Correct? So third path is hop count will be 4. So your distance vector protocol will always take the least one. Okay, it will always will go via R2 only. This way it will send the packet. Okay. So that is your distance vector protocol, which is whichever the hop count is less, that it will choose as the best hop path. That is your RIP version. But sometimes I don't want this to be gone in this way. Okay, I have some security issues in R2. I wanted to send via R5 or R6. Then that is not possible. Correct? Either I have to shut the interface, like that I have to do. Otherwise, I should not give routing itself. That's the way. I don't want to do that. So that's why we are not preferring distance vector protocol nowadays. We are only preferring link state and hybrid. Okay, any doubt on your distance vector? Its metric is hop count and it is going to choose the least hop count to reach from source to destination. Okay, now we'll see link state.
Why 2 seconds?
What?
The R2 has some security issues.
Mhm.
And why
Security issues in the sense I don't want more traffic to be sent in R2. I want because it might be connected like this also, right? So what if there is another multiple routers are connected via R2? So every traffic will go via R2. So high bandwidth overload will happen. I don't want that to happen. So that's why I'm going to manipulate the path. But you can't manipulate the path because hop count it will choose. Understood?
it totally depends on the hop count only.
It totally depends on hop count. Okay. Now we are going to learn the link state. Link state. Link state means it is going to use the bandwidth. Instead of hop count, it is going to use bandwidth. Okay, that information you have to give. So here I am connected with, say for example, 100 Mbps. Here 100 Mbps. Okay. And here again, I'm connected with, for example, say 50 Mbps. 50 Mbps. 50 Mbps. And here I've connected with gig port. So 1 GB per second. GBps. 1 GB PS, 1 GB PS, and 1 GB PS. Okay. So connected with gig port here. Here fast Ethernet and Ethernet cables. So your link state protocol, that is your OSPF, will choose the path based on your bandwidth, not the hop count. So here, if I send data, 1 GB of data is sent here. Then it will be fragmented to 10. Correct. But if I send the same 1 GB packet here, with one packet itself, it will go till here. So it will choose whichever the port has the highest bandwidth, that way it will take. It is not going to prefer the hop count. Which way I will go fast, that way it will take. Okay. For example, to reach the third floor. Okay. Or say there is 10 floors. Okay, 10 floors. I want to reach the 10th floor. I'm sitting in second floor. I have a door there, door here, and door here also. Okay. So this side, if I go, it is easy because there is the stairs. But this side, I have a lift. Imagine like that. So that I will choose this path, go via this way, and I'll take the lift and I go to the 10th floor. I'll not use the stairs. Likewise, whichever port has the highest to maximum throughput bandwidth, that way it is going to choose. That is your link state protocol. And which routing protocol is going to be worked on your link state? OSPF. OSPF is very important concept. Okay, so your OSPF works on link state protocol. And if they ask you what is link state, it calculates the path based on the bandwidth. That is maximum throughput. Maximum throughput. Okay. This is your link state. What is hybrid? Hybrid means it is going to calculate both distance vector and link state. That means it is going to calculate the hop count and also the bandwidth. Yeah. You can translate. Translate English to which language? Okay. So hybrid means it is going to choose both distance vector and link state. It is going to choose whichever the path is less and also whichever path has the best bandwidth. Okay. How you will see those things? They'll manipulate the path. Okay. So the metric way of EIGRP is K values, they say. I will tell you in EIGRP concept. K1, K2, K3, K4, K5 we have. So that is bandwidth, delay, load, reliability, and MTU. So they will manipulate all those values so that you can change the path also. That is supported in your hybrid. And hybrid is developed by Cisco and it is Cisco proprietary. So other vendors, for example, like HP, Nexus, other routers cannot use that hybrid version. Only EIGRP is supported. So EIGRP is actually Cisco proprietary. It's actually Cisco proprietary. That means only Cisco devices can, you can configure EIGRP, not another device. But now they made it open standard partially. Basic level of EIGRP can be done in other vendors, routers. That is HP, Nexus, or Juniper, whatever. But there are so many concepts in your EIGRP, those advanced level concepts you can't perform. Basic level routing you can do. So that's why they say it as partially open. And hybrid is a Cisco proprietary. Okay, so you have three things.
Sir, I have one doubt in this link state. Here you told no link state.
Yes.
In this, like let me clarify. It will select the route path which is having highest bandwidth, right?
Correct.
So, like in these three, which it will select?
That is 1 Gbps. Because
Oh,
1024 MB you can send, right?
yes.
That's why.
Oh, it will not see the number of routers,
No.
number of hops taken.
No.
It will not.
Because this is not distance vector protocol. This is a link state protocol.
Link
Link
state.
state protocol will always choose the bandwidth, not the hop count.
That is highest bandwidth it will
Correct.
select,
Yes.
not lowest.
Not slowest.
Oh, number of hops, that distance vector means lowest, right? Lowest
Yes.
number of.
Yes. Yes. Correct. So that's why your RIP version will choose this path. R2 and R3 it will reach. Whereas your OSPF will choose R5, R6, R7, and R8. That way it will choose. Because that is the fastest. Okay? Or that time you will manipulate according to our need. It will choose the path initially through R4. If it's sending the data through R4 depends upon the neighborship. If it's forming the neighborship there first, then it will go through that way. And if I don't want to send it that way, that also you can do. What?
It's not dynamic.
It is dynamic because see, I'm here, I have two paths. I can go by this way, I can go by this way. Okay. Two ways are there. But I have my neighborship. I have configured this neighbor first. So this neighborship will be formed first. So then I'm giving that command. So the second neighborship will be formed there. So I'll go via this way. See, this is for just understanding purposes. In your real time, it is not going to be like this. So you will have two routers. Okay. You will learn in CCNA also. So a packet will be gone via this router. Suddenly, what if this router goes down? Immediately it will go via this router. We can't have, a router going down or switch going down. How many links a switch is connected? Not with one link. Maximum 16 links can be connected. And at a time, 8 links can be active. Not one link, 8 links can be active, and 8 links also will take the data. So what we are going to do, 8 links we are making into a one link. Okay, and accordingly we'll spread the data so that every data will be sent through 8 links. These things I'll show you in practicals. In switching concept you have. Okay, so according to our use, we can change everything. Your CCNP routing you will learn. Okay. All right. Now come to the PPT. So this is your types of routing protocol. Static, default, dynamic. Under that we have IGP and EGP. What is IGP? Same autonomous number. EGP is different autonomous number. This totally a CCNP topic, so we'll leave it for now. Path vector, that is BGP. Okay, and IGP we have distance vector, link state, and hybrid. Now we have learned what is distance vector, what is link state, and what is hybrid. Correct? So this individual routing protocols we'll learn in upcoming classes. Okay, so I will give you all notes for RIP version, OSPF, and EIGRP also. Okay. So what are loopback interfaces? Loopback interfaces are logical interface, they are not physical. That is 127.0.0.1 we have, correct? We are going to ping that to check the NIC card, NIC card in your laptop. Likewise, in your routers, okay, every time we are not using this physical interface to check the connectivity. So what I'm going to do to create policies, I'm going to create a loopback addresses. Okay, your physical interface can go down. Okay, but your loopback interface will never go down. Loopback interfaces are always up in state. For example, I'm taking one router. Okay, so I'll first configure the IP address and I'm giving no shutdown. Now, after giving no shutdown, can you see status up? How to check the IP? IP interface brief. Here you can see it is up. What are the others? Others are in down state. That is 0/1 and 0/2. Now I'm going to create a loopback. How I will create a loopback? I'll say interface loopback. These many loopbacks you can create. Okay. So I'm just giving number 1. Interface loopback 1. Once I give interface loopback 1, immediately change state to up. Did I give any no shutdown command? No. So this interface will never go down. See, do show IP interface brief. Here you can see loopback 1 is created. And IP is unassigned, but the state is up. So this interface will never go down. To check the connectivity, we are using this loopback interface, and to create policies and all, we are using this. Okay. So I will say interface loopback 1 IP address. I will say 2.2.2.2. Okay. Now say do show IP interface brief. See 2.2.2.2 is there. Okay. Likewise, you can do the you can add the loopbacks and create multiple policies to check the packets and also to check the connectivity we are using this. See here. So loopback interfaces are logical interface. We are not creating it on the physical interface. Loopback 1, I said. Did I go to gig 0/0? No. Did I go to gig 0/1? No. I'm creating a separate interface. That is your logical interface. Okay. So they allow you to assign an IP address to a router which is not tied to a physical interface. We are creating it as a virtual interface. Because they don't have a physical attribute which can fail, loopback interfaces never go down. Because already it is a logic. It is not a actual port in your router. Correct. So that's why it will never go down. Loopbacks are treated as separate broadcast domain. That means they are created as a separate networks. So inside the one router, I have multiple networks inside itself. Okay, they are separate broadcast domain. For example, if I'm connected with another router here, okay, will they able to communicate without routing? Yes or no? Yes, because they are directly connected. Simple. Correct. No routing is required. But if I have a loopback here, 1, 2, 3 loopbacks I have. Will this router, it is directly connected to router. Will it be able to communicate or not? It should or not? It should. But it will not communicate. Because these loopbacks are separate broadcast domain. Separate broadcast domain as in separate networks. They're all different networks. So this R2, though it is connected directly to router 1, it will not be able to reach this loopbacks. He can reach this interface. This interface he can reach, but he can't reach this loopbacks. That is the difference. Okay. I will show you in practicals very clearly. Don't worry. Okay. And also, I'll give you one more important thing. AD value. AD value. Administrative distance value. Okay. Write down. It is used to rate the trust. Write down these AD values. Written. So what is this AD values? It is used to used to rate the trustworthiness of routing information received. That means, so I have R1, R2, R3. Okay, to reach my source to destination, I've configured RIP version, OSPF, and EIGRP. Three things are there. Okay, so which protocol it is going to choose? It will choose the least AD value. Always it will choose the least AD value. Which is the least AD value? Here, we are using 170 exterior. Forget this 90 as of now. We are using 170. So we have 170, 120, and 110. 110 it will choose. That means it is going to choose the OSPF. Okay, though we have RIP and EIGRP, it will choose the OSPF. What if I have static routing? Which way it is going to use? Static routing, because it has least AD value. So you can write it down in here again. So range is 0 to 255. Okay, and then least AD value is considered as the most trusted path. They will ask you what is AD value and what is the use of AD value. So then your answer should be AD value is used to trustworthiness of the routing protocol. That means the information is received. So for example, if there are multiple dynamic routing protocols configured, according to the least AD value, it is going to choose the path. Okay. And they'll ask you what is the AD value of OSPF, your RIP version, all these things they will ask you in interviews. This is important thing, AD value. Okay. Written? Okay. So today we have seen what is routing, router, route, all basics of routing. And under routing, what we have? Static we have that we are going to manually configure. Dynamic default is also dynamic. Dynamic means automatically it is going to choose. In under dynamic, we have two categories, IGP and EGP. EGP means different AS number. IGP means same AS number. Under IGP, we have distance vector. We've seen what is distance vector. We have seen what is link state. We have seen what is hybrid. Okay. Leave the EGP as of now, that you will learn in your CCNP routing. Okay. The static routing we'll see tomorrow. Before that, today I have to take you to lab also. So I will finish the class little early. How the practicals I'm going to do, that I'll show you. So mostly even in your CCNP, they are following this method. And if you do it by this method, your understanding will become very easy. Initially. How many networks I have here? 7 networks. 6 network. So this is one network. 2, 3, 4, 5, 6. 6 networks we have. Correct. So how I'm going to assign the networks here? How I'm going to assign the network and how I'm going to assign an IP? That I'll show you. See, here between router 1 and router 2. So I'll simply say 192.168.12.0. Okay, so the third octet will be the router's information. Here, what is the router? Number 1. Here, number 2. So that's why I said 12.0. So here I'm going to say 192.168.23.0 because it is between the router 2 and 3. Here I will say 10.11.34.0. The first two octet, it doesn't matter. Okay, your consideration should be on third octet. Here I said 3 and 4. Why? Because it is between the router 3, 4. Here I will take 111.112.45.0. Okay, because it is between 4 and 5. Here I'll say 56.56.56.0. Don't worry about these 56. It doesn't matter. Look on the third octet. Here I will take 45.45.67.0. So based upon the router numbers, I'm going to take the network to make it easy for you. So in your real time, it will not be like this. It will be 111.158.168.204. Like this it will be. But here I'm going to go with what? The router numbers so that you will understand it clearly. Okay. And all the subnet masks are CIDR 24. Everything I'm going to take it as CIDR 24, that is 255.255.255.0. How many IPs you will get from CIDR 24? 254 valid IPs, 256 IPs you will get. Okay, correct. How I'm going to choose the IP here? IP, since it is router number 1, I'm going to choose dot 1. If it's router 2, dot 2. Here, dot 4, dot 5, dot 6 and dot 7. Like this, I'm going to choose the IP. So what will be the IP of this gig 0/0? Tell me. This IP. So first of all, see the network. What is the network? 192.168.12. So 192.168.12. What is the router number? 2. So I'm going to give 2. Okay. And what will be this interface? So what is the network here? 192.168.23. What is the router number? I'm going to give 2. Come to this router. Router number 5. Gig 0/0. 111.112.45.5. Because router number is 5. What about this interface? 56.56.56.56.5. What about this interface? 45.45.67.7. This interface? 45.45.67.6 because of router number. So when I say 97.98.45.4, you can forget this 97 and 98. I said 45.4. So that means you have to imagine it is between router 4 and router 5. 45. And I said dot 4. That means what? On router 4. So this IP is on router 4 between the routers router 4 and 5. If you follow this method, your understanding will become very easy. I suggest you go with this method. Okay? Till your CCNP, you can go with this method only. So that you don't have to keep remembering multiple IPs. So if I give random IPs, you can't remember it. Okay. And your troubleshooting purpose also will become very difficult. Initial stage. So in your CCNP, you will take multiple routers, 8, 9 routers you will take. In that scenario, it will become very difficult. So follow this method. Any doubt how I'm going to assign this? Clear, right? Based upon the router number, I'm going to give the network. Between routers, I'm going to give the network, and based upon that particular router, I'm going to assign the IP. Clear? Okay.
That third octet only we need to keep the numbers between that router.
Yes. Because I'm taking CIDR 24. So the third octet, first 3 octets will never change. Correct? Only the last octet is going to change.
Class C IP address.
Yes. So that's why third octet I'm going to give the network number. And everything is CIDR 24. Okay? All right.
Sir, the one there that between R2 and R3. Now, can you say for R2 and R3 what it is IP address?
See, between R2 and R3, we have 23.0, 192.168.23.0. So
Okay.
here IP will become 23.2 because router number is 2.
Okay.
Here gig 0/0 it will become 23.3 because router number is 3. But this interface it will become 34.3 because router number is 3 but network is 34.
30,
Here what it will become? 34.4.
10.11.34.4.
Here 45.4. Here 45.5. Here
Okay, okay, understood.
56.5. Like that it will keep on going. Okay. Any other doubt online guys? Okay. Clear, right? So today we have seen only the basics of routing. What is routing? Why we use routing? What is a routing table and all? So in upcoming classes, we will perform routing. Okay, that is tomorrow we will see static routing completely and default routing. Okay. On Friday's class, your RIP version 1, version 2 and AHRP. Monday we'll see OSPF so that your routing is over. Okay. See, today itself I could have taken static routing and finish it off. But it's not, your strength is also good. You have like 25 people coming. So we'll take it slow. No issues. Okay. And today I'm taking it to lab anyways. So that's why I'm going to wind up the class early today. Okay. Online guys, any other doubt? No. Okay.
No, sir.
So, all right. So today we are going to physical lab. So I'm taking the students to lab. So I will finish early. So we'll see you. I will see you guys tomorrow. Okay. Thank you. Sri and you take the laptop with you.